Auzubillahi minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum rahmatullahi wabarakatuh. Today we are going to start calculus. In calculus, limits. Okay. Some important formula I am going to write here. Limit x tends to a, x power n minus a power n divided by x minus a. Whenever is there, the limit of this is nothing but n into a power n minus 1, where x is not equal to a. So, x is not equal to a means if x equal to a, in denominator we got 0, so it is not defined one, we will get infinity. Any number by 0 is infinity, so undefined limit. Limit must be a value of limit must be known. It may be 0 or any other thing, but not infinity. So, this is the first formula. And second, limit whenever x tends to 0, sin x value tends to 0. Sin 0 is 0, that is why. Third one, limit x tends to 0, cos x. Cos 0 is 1. So, this is that value. Limit x tends to 0, if sin x by x is there, then we have to write directly whenever sin x divided by x is there, we have to take 1. Limit x tends to 0, 1 plus x whole power 1 by x, then this is e. Next formula, limit x tends to 0, e to the power of x minus 1 divided by x is there, so this equal to 1. Four, 5, 6, this is seventh one. Limit x tends to 0, log 1 plus x divided by x is always 1. So, these are the special formulae. Directly you can have a bit like this. So, you have to substitute this value to get the answer. Okay, for competitive exam, sometime you will get this bit equal to dash 1, 2, 3, 4, where 1 is there, that is your solution. For this is also this. For 1 plus x whole power 1 by x is there, then you have to write e. And for sin x by x 1, cos x 1, and sin x 0. If function is in this form, so this is n a n minus 1. So, we will solve the number of problems using this formula. Now, basic theorems on limits. Here limit LT we are writing, limit LIM or LT. Limit LT, that is limit x tends to a Cx. C is a constant, so we can separate the constant. It is in a product form. So, constant into limit x tends to a x. Just you separate the function of x and constant, so it not affect the constant. Limit x tends to a, two functions are there. So, we can separate the limits for all two functions. So, limit of x plus is there. So, we have to write plus. Limit x tends to a h of x. Okay. Like this, sum is there, we can separate each and every function. If 2 are there, 2, or if 3 is there, you have to write 3. So, using separation we can allow. Thus, suppose see limit x tends to a, there are 3 functions gx plus hx plus px dot. So, we can separate this. This is limit x tends to a, one time with x plus limit again we are applying for other one, other function hx. Okay. plus limit x tends to a px, like this dot dot we can go. Okay, and for product is there, also we can separate fourth one, limit x tends to a gx into hx is there. So we have to, we can separate this also, limit x tends to a gx, product, again we have to take product of limit x tends to a h of x. So these are the direct functions applying limits. Using these basics theorems we can solve the problems also. Now quotient for fifth, just see, this is also a basic. If gx by hx is there, so again we can separate the limit for this x tends to a g of x divided by limit x tends to a h of x. So this is called quotient rule for limits. So using these 5 limits and the formulae, we can find the limit of different things. Okay. Now question, find the value of limit x tends to 0, 10x. Here 10 is constant. Okay. We can use basic formula, this limit x tends to a, cx is there. So c into limit, we have to apply limit x tends to a x. Okay. This using this formula, limit x tends to 0, 10x, nothing but 10 into limit x tends to 0, x is there. Okay. Now apply this limit. If you apply, you will get 10 into x is 0. This is 0. So 10 will does not affect the limit. Being constant does not affect the limit. Apply 0 directly, 0 into 10, you will get the 0. That's enough. So second question, on second one we are taking limit x tends to 0. Suppose your function will be like this, 5x square plus 3. Now you have to apply the limit here. You can separate the function if you take x and plus 5 also. Okay, 3 values. This is fx, this is gx. So we can write limit, this is our gx plus hx plus px also, there three values are there, so we can separate this. So we can write this limit x tends to a gx, again limit x tends to a hx plus limit x tends to a px. Okay. So now you have to apply the limit. Therefore this main function is what, limit x tends to 0, 5x square plus 3x plus 5. 3 functions a, 1, 2, 3 plus is there, so we can apply this limit x tends to 0, 5x square plus limit x tends to 0, 3x plus limit x tends to 0 constant itself. So this is what we will get, this 5 into 0, 5 into 0 plus 3 into 0 square, this is 0 and constant as it is 5. So we will get that 0 plus 5, this is nothing but 5. So directly applying 0 or separate, we still we will get the same value. So using this second basic formulas, separate, we can get this value. See here question is in quotient form, fraction form. So that is applying quotient rule. This is x tends to a g of x divided by h of x. So what we have to do? This is nothing but applying limit for upper numerator g of x separated by limit, again applying with denominator. If you apply direct or you apply individual, divide that, you will get the same. So this is also same, we are applying here. So this is our function this divided by x plus 4. Now separately we have to take a limit. Limit x tends to 0. We can apply now for denominator as well as numerator and denominator. Okay, here x plus 4. So direct we applying it. Limit x tends to this 5 into 0 square plus 3 into 0 plus 7 as it is. Here in denominator we applying 0 plus 4. So this is nothing but 0 plus 7 divided by 0 plus 4. Okay, 0 plus 4. So like this we will get 7 by 4. The limit of this is 7 by 4. Now using formula we can find the value. Okay, evaluate limit x tends to 2 x cube minus 8 divided by x minus 2. Just see here, this is x cube is there, so it is also a cube of another number, that is 2 cube. We can write 8 as 2 cube. So just see that x cube minus 2 cube divided by x minus 2 and limit also same. Whenever this is in a form of this, x tends to a, x power 3, a power 3 divided by x power n, a power n, x minus a. 1, 2, 3, 4, 5, 6. If these 6 terms are same, powers also same, then we can apply this formula n minus 1. Why? Because if you directly apply, you will get this one is 0. If you apply 2 cube minus this, 2 minus 2, 0. In denominator, numerator 0. So this is not valid limit. So we have to apply this formula to get this value, and the denominator will get cancelled and you will get the value as it is equal to na n minus 1. Okay, very important one. If you apply directly, we are saying directly apply limit. So what happened? If you are directly apply limit, what happened? Just see here, limit x tends to 2 x cube minus 8 by x minus 2 is nothing but 2 cube minus 8 by 2 minus 2. This is 8 minus 8 by 2 minus 2. This is 0 by 0. So this is unknown value. 0 by 0 is unknown value, infinity. So we have to utilize this formula using this condition. So we will get the limit. Now we have to see this, limit x tends to 2 x cube minus 8 by x minus 2 is nothing but we have to again separate it. Okay, make it as a formula, x cube, this is 2 cube, x minus 2. Okay, 8 equal to 2 into 2 into 2, that is 2 cube equal to 8. So now we can apply this limit x tends to a, x power n, a power n divided by n minus a, then we have to write like this. This is our limit na n minus 1. So now we are applying x minus 2, x cube minus 2 cube divided by x minus 2. So we have to write n. N is what? Power 3. N is what? 3. A is what? 2. A is what? 2. So 2. 3 minus 1. So this is 3. 2 to the power of 3 minus 1 is 2. So this is 3, 4. That is 12. The value of this limit when x is applied to 2, we will get 12, not 0 by 0. So this way we can solve the number of problems. Suppose we are taking x tends to 3, x power 4 minus 81 by x minus 3. Just apply 0 here. Directly if we apply 3 minus 3, 0 by 0. So again we have to write 81 as a factors. 3, it goes with 3, 27 times. 9 times, it goes with 3 times and 3 ones. So we have power same, limit x tends to 3, x power 4, 3 power 4 divided by x minus 3. Now we can apply the formula. Okay, this is nothing but n a n minus 1. So this is 4, 3 to the power of 3. This is 4, 3 to the power of 3 is 27. Now you multiply 8 to 108. So this is 108. Take one more example. Limit x tends to p, x power 5 minus p power 5 x minus p. If all these are same 6, so we can apply directly formula. N, a is nothing but p. N is what? Our power. P, a is what? Our value p. So p power 5 minus 1. So this is nothing but 5 p to the power of 4. 5 into p to the power of 4 is a solution. Okay. Sometime you will have in denominator. Sometimes you have these type of quotients. Powers also there. So we cannot use directly that formula. So we can make it, or we can divide and multiply by this one, x minus 2. For both one, we can, here this also power, this also power. So just see this can be like this. 2 here x power 4 minus 2 power 4. In denominator x, 4 can be written 2 power 2. 2 to the power of 4 is 16. 2 to the power of 2 is 4. So all are in powers. In denominator we need not be have a power form. So we can divide and multiply both numerator and divide and multiply both numerator and denominator by, or divide both numerator and denominator by x minus 2. So we can write this limit x tends to 2, x power 4 minus 2 power 4 divided by x minus 2 whole divided by x square minus 2 square divided by x minus 2. This both denominator get cancelled. Again you will get this value. Now apply the limit for upper value. Limit x tends to 2 for upper, x power 4 minus 2 power 4 divided by x minus 2 whole divided by limit x tends to 2, x square minus 2 square by x minus 2. Now apply the formula for upper. This is n equal to here 4 and a equal to 2. Here n equal to 2, a equal to 2. So this is the different. So n 4, a 4 minus 1. Here n is 2, a is 2, 2 minus 1. So this is nothing but 4, a is what? 2. So 2 to the power of 3 and here 2 to the power of 1. So this is nothing but 4 into 2 to the power of 3 means 8. Here 2 to the power of 1 is 1. So this is nothing but 32 and this is 4. If you divide it, you will get 4 8s. So like this we can solve the if power is there. For this you can write this formula also. Whenever this limit is there, x to the power of n minus a to the power of n divided by x to the power of m minus a to the power of m. Whenever this is there, n by m, again you have to write a to the power of n minus m. This is a shortcut for finding the value of this type of functions. Now we are going to use this. Take one more question. Limit x tends to 3. We are taking 3. X power 7, 3 power 7 divided by x power 3. So take 4. X power 4 minus 3 power 4. So this is here what? N equal to 7, m equal to 4 and a equal to 3. So we can write direct answer this 7 by 4 m by n. Okay. Here a is what? 3. 3 power 7 minus 4. So this is 7 by 4, 3 to the power of 4. Okay. You can write this 7 into 81 by 4. So this is your solution, or multiply it. 7 ones are 7, 7 eights are 56 by 4. So it not goes, so keep it like this. Directly we using this formula we can find the value. Okay. If you want to check whether this is true or not, for this question we can solve this. Limit x tends to 2, what we got, this is 16 and this is 4. Here dividing and multiplying rule we get the answer as 8. This is 8 na. Now we are going to check with this formula. What is that? Limit x tends to a, x power n minus a power n by x power m minus a power m is there. So n by m, a power n minus m. Now applying this limit, limit x tends to 2, directly we are going to apply this formula for this question and answer should be 8. Okay. Let us see here, x to the power of 4 minus 4 to the power of 2 to the power of 4 divided by x square minus 2 to the power of 2. Now upper powers are 4. Okay. Denominator powers m is 2, n is what? 4, m is what? 2, a is what? Again 2. So a is 2. 4 minus 2. So this is, if you get cancel, you have to 2 to the power of how much? 4 minus 2 is 2. So 2 into 4, that is 8. By separate method or applying dividing both numerator and denominator by x minus a, or using this formula we can find the value of limit. Now next question, this is there. Now apply the limit directly. Okay, this is the function. Limit x tends to 2, 2 into x plus 3. 2 into x, x is how much? 2 plus 3 as it is and plus 7 also as it is. Now this is nothing but 2 into 5 plus 7. So this is 10 plus 7, that is 17. So this is 17. And second question, limit x tends to 0, x square plus 3x plus 7 is there. Apply the limit x tends to 0 square plus 3 into 0 plus 7. So this you will get this 0 plus 0 plus 7, that is 7. Okay, like this we can find the limits. Now one more question, 3. Limit x tends to 5. What given? X minus 5 by x plus 2. Now apply the limit 5 minus 5, 5 plus 2, that is 0 by 7 is a defined value 0. So 0 may be a limit, but number by 0 by number is a 0. Number by 0, if you got number by 0, this is not a limit. Whenever here 0 by 7 is 0, 0 approaches, it is a value. So this exists, this limit exists. Now the numerical value sum. Now see here, px square plus px plus q divided by ax plus this. Directly apply the limit, p into 0 square, p into 0 plus q divided by a into 0 plus r. So this is nothing but 0 plus q divided by 0 plus r. So this is q by r. The limit of this function equal to q by r. Now this is there, 5 square we can write, 5 is there, but here plus and minus is there. So we can't apply the formula, we have to directly apply it. So 5 x tends to 5, 5 square minus 25 divided by 5 plus 5. So this is 25 minus 25 divided by 10. So this is nothing but 0 by 10, this is infinity, not infinity, it is a 0. So sometime we can have plus and minus between them. If in denominator minus, yeah, we have to apply the formula, or otherwise the both are not same, not negative, so we have to apply directly, check that the value is correct or not. Okay, and now see this question, if you apply directly 1 by 3, you will get negative value, 0 by 0. Just see here, 9 1 by 3 whole square minus 1 by 3 1 by 3 minus 1. So this is nothing but 9 into 1 by 9 minus 1 divided by 3 into 1 by 3 minus 1. This is 9 by 9 minus 1, 3 by 3 minus 1. So what is this? 1 minus 1 by 1 minus 1. 0 by 0, infinity, not a defined one. For that, what you have to do? We have to change or cancel the value which makes zeros. Okay. So again we have to apply limit like this, or check that with whether it is in a formula or not. 9x square 1 by 3, 3x minus 1. Now we can write this as a square formula. Okay, make it square. So this is 3x whole square and 1 square. This is 3x minus 1. So upper value is a square minus b square formula. We apply the a square minus b square. A square minus b square is a plus b into a minus b. So this is nothing but 3x plus 1 and 3x minus 1 divided by 3x minus 1. So this part which makes limit as 0 is gone. So applying limit x tends to 1 by 3. Here we have what? Here we have this function is there, 1 by 3, 3x plus 1. Actually this is nothing but 3x plus 1. Now apply it, limit 3 into 1 by 3 plus 1. So this is 3 cancel, 1 plus 1, that is 2. Not it is infinity, it is 2. So like this, sometime we have to make the numbers, make it cancel and apply, or otherwise you can apply the formula also. This also 3x, multiplying this you will get 3 minus 1, 3x tends to that. Okay, so applying that formula also you can do this. Let us see here, you have to make limit as same. Here we are applying 3x square minus 1 square. In denominator 3x minus 1 is there, a same, squares are there. Here not there, so multiply with 3, 3x, 3 into 1 by 3, these 3 can cancel. So limit 3x tends to this, again this is square minus 1 by 3, this is equal to n. N is what? 2. A is what? 3x. A is what? 1 again. Here n is 2 but a is 1. 1 minus 1. Sorry, n is what? 2. 2 minus 1. So this is 1 power 1. 2 into 1 power is 1, 1. 2 ones are 2. So this and this limit are same. Applying formula or otherwise making some arrangement using formulas like a square minus b square, we will get the same value. Now this is our formula, limit x tends to sin x by x equal to 1. So find the value of sin this, sin x square by 5x square, if it is there. Now we have to make some corrections. Constant is there, take out constant. So this is 1 by 5 limit sin of x square by x square. So this is 1 by 5, this 1 by 5 constant as it is. Now apply the limit, the x by same, these two values are same, so we can apply it 1. So this is 1 by 5. Second question, if it is like that, x tends to 0, sin 4x power 3 by 12x power 3 is like that. So again we can apply, make it same, then we can apply the limit. So we can write this x tends to 0, sin of 4x cube divided by x cube are same. Here we have to take constant 12 x cube. So make the set limit same, we can write this is as limit x tends to 0, sin of 4x cube divided by 3 into that value, 3 into 4x cube, 3 4s are 12. So take out 3, 1 by 3 limit sin of 4x cube divided by 4x cube. So limit of this x tends to 0 is what? 1 by 3 into 1. So this is 1 by 3. Like that we can find the values using formula also. Now see here, limit extends to 0, this is there. So you can solve the number of problems using this formula. 1 plus 2x by 2x is there. Then again applying this formula we will get this. So very easy if you apply this formula. Question number 2, limit extends to 0, log 1 plus 5x square by 5x square is there. So again we have to write the limit of this is nothing but x is there, a x, here x is equal to 5x square. Both x are same, 1 plus this we will get the same value. Using and applying this way we can find the number of, we can solve the number of problems. Thank you.